In this lecture, we are going to discuss a representation of graphs. So there are two standard ways to represent a graph. First is adjacency list and second is adjacency matrix. These two methods, they can be used to represent both directed as well as undirected graphs. So first we see adjacency list representation. So this is our definition part. The adjacency list representation of a graph G equal to V consists of an array of V vertices. So if in a graph there are 10 vertices, then our array will contain 10 elements, or the size of the array will be 10. For each vertex U belongs to V, the adjacency list contains all the vertices adjacent to U in G, and the ordering, it is not important. So we take an example and see how it works. So here is our first example. It is for undirected graph. In this graph there are 5 vertices V1, V2, V3, V4 and V5. So we take an array of size 5 and the elements, we name them V1, V2, V3, V4 and V5. Now we can see in our example, from V1 we can go to V2 or V3. So these are V2 and V3, they are immediate neighbors of V1. So we can take any one first. Here I am taking from V1, we are moving to V2 and then V3, and we represent it by these boxes. Now in the last box we put a null sign here. It's a null pointer, means we can go nowhere from here. Similarly, from V2 we can go to either V1, V5 or V3. We take any one, ordering is not important, as we see. So I am taking here V5 first, so it is V5. From V5 we can move to V1, so I am taking V1 next. From V1, after V1 we take V3, so here is V3, and in the last box, in the last node, we are putting a null pointer here. Similarly, from V3 we can go to either V1, V2 or V4. So from V3 I am taking V1 first. From V1 next I am taking V2, and then V4, and finally in the last node put a null pointer. Similarly, from V4 we can go to V3 only, so there will be only one node, V3, null pointer. From V5 we can go to V2 only. So this is our adjacency list representation of this undirected graph. The next example we take is for a directed graph. We take a directed graph and create adjacency list for that graph. So this is our directed graph, and we create adjacency list representation for this graph. So from V1 we can go to V2 and V3, but vice versa is not possible because graph is directed. From V1 we can go to V2, but from V2 we cannot come to V1. Similarly, from V1 we can go to V3, but from V3 we cannot come to V1. So I am taking from V1 V2 first. From V2, after V2 we can take V3, From V2 we can move to either V5, V3 or V4. So I am taking V3 first. So here is our V3. From V3, after V3 we are moving to V4. So V4 next. After V4 I am taking V5 and finally null pointer. Similarly, from V3 we can move to V4 only. So V4 only, it is our V4 null pointer. From V4 there is a self loop. So from V4 only. From V5 we can move to V4 only. So V4. This is our adjacency list representation for undirected graph. Next, we see adjacency matrix representation for both directed as well as undirected graph.